Okay, today we're going to actually do a lab, okay, on subnetting. Okay, basically the first part will be on splitting up, okay, a given network, okay, into smaller part, okay, making use of fixed length subnet mask, okay, FLSM, which stands for fixed length subnet mask. And the second part of the lab sheet, okay, basically we're going to do some calculation on the other variation, which is the variable length subnet mask. Okay, the differences between fixed length subnet mask and variable subnet mask, basically for fixed length subnet mask, okay, basically if you are given, let's say a group of addresses, okay, basically you split them equally. Okay, for example, let's say you have this group of addresses, okay, whereby you have a 24, okay, the subnet mask is 24, which basically will give you 8 host bit. Okay, because the number of 0 equals to the number of host bit. Okay, so we know that given the 8 host bit 2 to the power of 8, we will have 256 IP addresses. Okay, so if we need to split this up into a smaller group, like for example into half, that means that 256 divided by 2, each half will be having 128 address. So how do we split them up? Okay, basically by manipulating the subnet mask. Okay, by manipulating subnet mask. So in this case, basically by changing /24 to become 25, okay, we are able to split them up. Okay, and we are even able to split them into smaller pieces depending on our need. Okay, and why do we need to split them up? A very simple answer is basically the efficient usage of the IP address. Okay, for example, if you're given a 24, you have 256 address. But let's say you only need 45 IP. Okay, there's a lot of address that is being wasted. Okay, that is why we need to know how to do subnetting in order to split up the network. Okay, so the other variation, variable length subnet mask, VLSM, is a bit more difficult because instead of using splitting up, let's say splitting up, a block of address equally. Now you can split them up, in terms of the requirement of the different IP address group. That means that you can split them up unevenly. Like for example, group 1 I need 128 address, group 2 I need 64, group 3 I need 32 address. So all of them basically will be using different subnet masks. Depending on the requirement of the number of IP address that's required. So let's start by actually going through the exercise now. Whether is it a fixed length subnet mask or variable length subnet mask. So you can see on my left hand side, basically let's start off. For each of the subnetting requirement, determine the new subnet mask written in decimal dotted notation. And the number of usable IP addresses in each of the new subnet mask. So let's do the first one first. Copy and paste. So basically I will given this address whereby you have the subnet mask, which is a /24. Basically will be equals to 24 bits of 1. It means that 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 followed by 1 2 3 4 5 6 7 8. So basically you have 24 network bits and 8 host bits. 8 host bits. So basically you are supposed to split them up into two different subnet. It means that given a /24, this is your /24, you are supposed to increase your subnet mask. So that depending on the increment of the bit, it depends on how many group you have. So in actual fact, there is a fixed formula. If you still remember, how do we calculate the number of address in a group? For example, the 8 host bit basically means that 2 to the power of 8 equals 256 IP in the subnet. Okay, so how do we actually spin up into different group? It also make use of the concept of to the power. Okay, to the power. Okay, so from this, okay, think in terms of the fact that, okay, if I were to change, okay, instead of 20/24, okay, to 25, okay, to 25, okay, okay, 25. It means that now the new subnet mask will be 1, 1, 1, 1, 4, 5, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, dot 1, 0, 0, 0, 0, 0, 0, 0. Okay, so basically, okay, 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 adding, okay, adding 1 bit, okay, it means that, okay, we will have two, okay, groups or subnet. Okay, why? Because it's 2 to the power of 1. Okay, to the power of 1, which is equals to 2 subnet. Okay, so basically, if you make use of this concept that I just introduced, okay, you will know that, for example, let's say now I change, okay, /24, okay, to /26. Okay, what does it mean? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. 1, 2, 3, 4, 5, 6. Okay, it means that I, okay, adding 2 bit to my subnet mask now. Okay, which, okay, basically, okay, will give us, okay, give us 4 subnet. Okay, why? Because 2 to the power of 2, okay, is equals to 4 subnet. Okay, so, okay, it means that, okay, every time you increase the number of bit by 1, you are increasing, okay, to the power of 2, okay, to the power of 2. Okay, so it means that, for example, /24 to /27, okay, basically, okay, is, okay, I increase the number of bit by 3, okay, which will basically give you 2 to the power of 3, which will give you 8 different subnet groups. Okay, 8 different subnet groups. Okay, okay. So basically, okay, making of this concept, you should be able to do the rest, okay, quite easily. Okay, so basically, you can see from here, okay, basically the first question, okay, basically as a, let's go through the first question again. Okay, basically we are supposed to split them up into 2 different subnet masks. Okay, so by splitting up in subnet mask, very simple. Okay, okay, we already did it already. Changing to /25, increase by number of bit. Okay, basically, okay, 2 to the power of 1, which will give me 2 subnet. Okay, it means that the new subnet mask will be 25. Okay, so 25, okay, will be equals to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 0, 0, 0, 0, 0, 0, 0. Okay, which is also equivalent to 255.255.255.128. Okay, if you do the, okay, binary to decimal conversion. Okay, so basically, okay, you can see that for each of the subnetting requirement, determine the new subnet mask, okay, written in decimal dotted notation coordinate, and the number of usable IP address. Okay, so in order to calculate the number of usable IP address, we will be looking at the number of host bit. Okay, so having a /25, we only have 70, okay, 70, which is 7 host bits. Okay, so in order to get the number of, okay, IP addresses, simple, 2 to the power of 7, which will give you 128 IP. Okay, but we need to 128 minus 2. Why minus 2? Because we need to minus off the network address and the broadcast address, which we cannot assign to any devices, which will give me 126 usable IP address. Okay, so that will be the answer for your first question. Okay, so let's do the second one. So same logic here. Okay, from if we increase to /25, I'm only going to get 2 to the power of 1, which will give me 2 subnet. Okay, which basically is not enough to support my requirement. Okay, so let's increase to /26, which is 2 to the power of 2, because I increased by 2 bit, which will give me 4 subnet. Okay, which is enough for my requirement. So it means that again I should be using /26, which will be equals to 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 and 1 2 followed by 6 0 1 2 3 4 5 6. Okay, which will be equals to 255.255.255.192 if you do the necessary binary to decimal conversion. Okay, so how many zero we have? Okay, the host bit is equals to 6. Okay, so basically it's 2 to the power of 6. Okay, which will give you 64. Okay, 64. Okay, but as mentioned again, okay, we cannot use all of them. So 64 minus 2. Okay, which is to minus off the network address and the broadcast address. Okay, which will give me effectively 62 usable IP address. Okay, so we have done the second one. Okay, so you can see that if you keep going on, basically it's very simple. For example, the third. Okay, the third question, okay, is to split up the /24 to 8 subnet. So going by /25 again, we only have 2 subnet, which we calculated above. /26, I will have 4 subnet, okay, which is calculated above also. So if I have 27, okay, basically, okay, it means that, okay, I'm going to have, I increase the number of bits by 3. So 2 to the power of 3, okay, to the power of 3, okay, which will give you 8 subnet, okay, which is enough for our requirement. Okay, so /27 will be equals to 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 and 1 2 3 followed by 1 2 3 4 5 5 0. Okay, which will be equals to 255.255.255.224. Okay, so that will be our decimal dotted notation for /27 subnet mask. Okay, and the host bit is basically we have 550. So 2 to the power of 5, okay, will give us 32 IPs. Okay, but we cannot use all 32 minus 2 because we need to minus off the network address and the broadcast address. Okay, which will give us effectively 30 usable IP. Okay, so that will be for the first part, question 1. Okay, let's continue with question 2. Okay, so instead of always working with /24, okay, we can even work with a smaller subnet whereby we need to actually split them up, okay, into, okay, smaller subnet or smaller groups of IP address. Okay, so you can see that, okay, basically instead of working with a /24 now, okay, /24 now, we are working with a /27. So it's still the same concept. Okay, so basically from /27, if I increase to /28, okay, basically, okay, I increase the network bit by 1, okay, basically will be 2 to the power of 1, which will give me 2 subnet. Okay, so but my requirement is 4 subnet, so same concept here. Okay, it's not enough for my requirement. Okay, so from /27, if I increase by 2 bit to 29, okay, so basically I'm going to increase my network bit by 2. Okay, so it will be 2 to the power of 2. Okay, we will equals to 4 subnet. Okay, so now my requirement is correct or enough. Okay, so that means that instead of using a /7, now my new subnet mask will be /29, will be equals to 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 24 25 26 27 28 29, followed by 30, okay, which will give me the 32 bits. Okay, so the equivalent decimal total notation will be 255.255.255.128.192.240.248. Okay, if you do the necessary binary to decimal conversion. Okay, so same concept as above. When we calculate from /24, okay, I got 3 holes bit. You got the 3 holes bit, okay, which is 30. That means that 2 to the power of 3, which will give me 8 IP. Okay, but we cannot use all 8 of them. We need to minus 2. Okay, because we cannot use our network address and our broadcast address. Okay, so I will left with 6 usable IP. Okay, so same thing for the next example, /25. Very simple. Okay, from /25, okay, if I increase to /26, okay, so basically I increase by 1 bit, okay, which will give me 2 additional subnet only, which is not enough for my requirement because I need 4. So /25, I increase to /27, okay, which I increase by 2 bits, okay, which will equals to 4 subnet, because 2 to the power of 2 is 4. Okay, then this will be my, okay, enough for my new requirement. So same thing now, /27 will be equals to 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 and 25 26 27, followed by 350. Okay, so the decimal total will be 255.255.128.192.224. Okay, so how many host bit do I have? 5 host bits. Okay, means, okay, 2 to the power of 5. Okay, which will give me 32 IP. But we cannot use all 32, we minus 2 because of the network and broadcast address. Okay, which basically left me with 30 usable IP. So that is how you basically calculate, okay, the number, the new subnet mask as well as the total number of usable IP address. So following up from question 1 and question 2, we're going to go on further, okay, by actually calculating the new subnet mask depending on our number of subnet required, and from there we're going to actually calculate and get the information such as the network address, the first usable, last usable, and broadcast address of every new subnet that I'm going to create based on the new subnet mask. So for question 3, okay, we know that given 172.16.128.128/26, okay, from this subnet mask /26, I'm supposed to create a from here I'm going to split this big group of network into 4 different equal size subnet. So based on the working that we've done earlier, if I increase the number of bit by 1 from 26 to 27, okay, I'm only going to get 2 subnet, which is not enough. Okay, then from /26, if I increase to /28, which will give me 2 to the power of 2, which will be 4 subnet. Okay, so this will be the new subnet mask that will fit my requirement. Okay, so /28 will be equals to 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4 followed by 4, 0. Okay, so my new subnet mask will be 255.255.255.240. Okay, so basically based on our understanding, okay, the new subnet mask I will have 4 host bit. Okay, basically equals to 2 to the power of 4. Okay, basically I will have 16 IP address in every subnet. Okay, in every subnet. Okay, so always know that, okay, when we are given the IP addresses, okay, normally it will be network address with the subnet mask. Okay, and that address will always be the first address, okay, or the network address, okay, of the first subnet or the first group. Okay, so this address will be the new network ID or the new network address of the first group, followed by the new subnet mask that we are going to use. Okay, and definitely, okay, previously we learned that given the IP address and subnet mask, we are able to use the binary bit conversion to eventually get our broadcast first usable and last usable. Okay, today I'm going to teach you a faster method. Okay, basically is the magic number, okay, method. What is this magic number method? Okay, the magic number method basically is, okay, basically make use, okay, of the total IP address in the group, okay, to get the next network address of the next subnet or the next group. Okay, because after all, we know that every subnet or every group, okay, what is the total IP address given the new subnet mask? In this case, for this case, /28 of 16 IP. So it means that, okay, my first my first network address, okay, as given above is 172.16.128.128. Okay, so it means that my second network address, okay, will be 172.16.128.128 plus 16. Okay, because every subnet has 16 address. So by adding 16, I will be able to get the second network address of the next group, which will be equals to 172.16.128.144. Okay, so that will be my next address, 172.16.128.144. Okay, and before I move, okay, so basically by doing this calculation, we are able to get the rest of our group, okay, if required. Okay, 172.16.128.144, which is the network address of the second group, plus 16. Okay, I'll be getting 172.16.128.160. Okay, that would be my next address, 172.16.128.160. Okay, and similarly, the fourth subnet network address will be equals to 172.16.128.160 plus 60, which will be equals to 172.16.128.176. Okay, 176. Yes, 176. Okay, so I will have fourth network address. Okay, so since we have the network address of every subnet, okay, always know that okay, it is always an address that is after the broadcast address of the next group. Okay, it means that okay, basically in order to get the broadcast address of the previous subnet, okay, basically you minus 1 from the network address. Okay, so see what did I do first, okay, before you okay actually okay try to understand. Okay, so in order to get the broadcast address of the subnet tree, okay, I need to actually calculate the fifth group. Okay, so basically one less than the network address 172.16.128.191. Okay, so you can see that okay the broadcast address is always one less than the network address of the flowing subnet. Okay, so basically you can see this happening okay for every single group. Okay, so basically because we are using the fixed length subnet mask, the subnet mask will all be the same. Okay, and based on understanding, if we have our network address and we have a broadcast address, very simple. Okay, basically we will have okay we will be able to calculate our first usable. Okay, because the first usable will be network plus 1, the last usable will be broadcast plus 1 minus 1. Okay, so basically you'll be able to actually calculate all the first usable and the last usable. Okay, so this is how you actually calculate okay the address range to be used okay for different subnet or different groups of network. Okay, so you can make use of the same concept to do your question 4. Okay, question 4. Okay, let's move on to another variation of the question. So instead of telling you the number of subnet that you need to create, okay, the question may be in another form that basically require telling you how many usable address that you should have. Okay, so based on this example, based on question 5, 6, and 7, is based on the other variation of the calculation. Okay, basically instead of telling you the number of subnet, now you basically are given the total, the number of usable IP address that you should have. Okay, it's nothing new. It is still the same concept. If you make use of the previous method of doing it, okay, it's just that instead of getting the answer directly by determine number of subnet, now you need to do the extra step in order to determine that by increasing the number of bit, okay, how many usable address do you have? Okay, so okay, let's try out question number 5 now. So for question number 5, you can see that I'm given a slash 24, but okay, I'm supposed to divide into 7 subnet. It never tell you how many subnet you need. Okay, but every subnet should have 100 usable IP address. So very simple. Okay, basically still the same process again. A slash 24, if you increase to slash 25, okay, which will basically give you two different subnet. But now we are not concerned more about subnet, but we are more concerned about the number of usable IP address. So for this case, instead of straight counting the number of subnet now, we need to actually reproduce the subnet mask in terms of the binary first. So 25 basically means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And 1. Okay, is 25 bits of 1 followed by 7 bits of 0. 1, 2, 3, 4, 5, 6, 7. Okay, so basically I will have 7 host bits Okay, basically means 2 to the power of 7, which will give me 128 total IP address. Okay, but I cannot use all of them, so 128 minus 2, okay, because I need to minus off the network and the broadcast, okay, I'll be getting 126 usable IP. Okay, so it means that, okay, 25 actually fit my requirement of at least having 100. Okay, but in the world of subnetting, okay, you must at least make sure that, okay, is the best fit. Okay, so we need to try out the next number. Okay, instead of increasing the number of subnet mask bit to 1, I'm going to increase to 26 and see, okay, can it also fit my 100 usable IP address? So you're going to keep increasing until you see which is the best fit. Okay, that means that the best subnet mask to use, okay, to minimize the number of IP address wastage. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 24, 25, 26, followed by 1, 2, 3, 4, 5, 6, 6, 0. Okay, so I have 6 host bits. Okay, basically it's 2 to the power of 6, which will give me 64 IP. Okay, so I don't even need to go to the next step to calculate the usable, because total IP address 64 cannot even fit my 100 usable IP. So it means that for this question, I will be actually using, okay, the /25 subnet mask. Okay, so same thing as what we did for the earlier question. The first address that is being given is always the first subnet, okay, network address, and the new subnet mask, okay, that I need to use will be a /25 equals to 255.255.255.128. So that will be the new subnet mask that, okay, I need to use. Okay, and based on what we understand, if I increase by 1 bit, it means that I will have 2 different subnet. Okay, because 1 bit, okay, to the power 1 is 2 subnet. Okay, so just now this table tell me I got, okay, 2 field to fill in. Okay, so using the concept above, same thing now. Okay, so I will have my first network address, which is given 192.168.0.0. Okay, my second network address, okay, will be equals to 192.168.0.0 plus, okay, 128 IP. Okay, because, okay, basically, okay, based on the previous, okay, working, we know that adding the total IP address will give me the network address of the new second group. It will be 192.168.0.128. Okay, so I will have my 192.168.0.128. Subnet mask is the same for both group. Oops, sorry. Okay, so this will be my subnet. Okay, since here's 0, let's use 0, and subnet 1. Okay, so, okay, same thing here. The broadcast will be 1 less than the network address of the next group. So very simple. 0.127. Okay, so in order to get the, okay, the broadcast address of the next group, okay, basically, okay, try to calculate the third network address. It will be 192.168.0.128 plus 128. You will find that basically you'll be getting 192.168.0.256. Okay, anyway, you don't have 256. But anyway, 256 minus 1, you will be getting the last address. Okay, so same thing here. Okay, network plus 1, okay, will be your, okay, you will have, okay, 192.168.0.1 for the network address. Broadcast minus 1, we will be having 192.168.0.126 for the first subnet. Okay, so same thing here. Okay, network plus 1 equals to 129. Broadcast minus 1 will be equals to 254. Okay, so now you will have, okay, the range of usable address to use for the two subnet or the two groups of network that you have created. Okay, so let's do question 6 to reinforce your understanding again. Okay, so for question 6, I'm supposed to divide this address to 40 IP address each. Okay, so same concept here, /25, I increase to /26. Okay, will be equals to 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26, followed by 6, 0. Okay, so how many host bits do I have? I have 6 host bits, which will equals to 2 to the power of 6 will be equals to 32. Okay, IP. Okay, so 32 IP, no, sorry, 64 IP. 2 to the power 6 is 64 IP. Sorry, okay, 64 IP. So 64 minus 2, because I cannot use the network and the broadcast. Okay, so I'll be left with 62 usable IP. Okay, 64, 32, yes, correct, 62 usable IP. So apparently /26, okay, is able to accommodate for the usable IP address. Okay, but definitely, okay, we always need to have the most efficient. Let's try out. Okay, instead of 26, let's increase from 25 to 27 and see whether does it fit. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 25, 26, 27, followed by 1, 2, 3, 4, 5, 5, 0. So we have 5 host bit, which is equals to 2 to the power of 5, which will be equals to 32 IP. Okay, don't even need to calculate the usable IP because I only got 32, cannot even fit my 40 usable IP. So it means that my appropriate fit subnet mask will be /26. So it will be 255.255.255.192. Okay, let's write it down here. 255.255.255.192. Okay, so same thing. The address given is always the network address or the first address of the group. Let's copy down. Okay, so what we need to do next is to calculate our subsequent group network address. Okay, so our first network address is 192.168.1.0. Okay, so our second network address will be equals to 192.168.1.0 plus the total IP address. In this case will be 64. Okay, 192.168.1.64. Then the third network address will be 192.168.1.64 plus 64 again. Okay, which will give you 192.168.1.128. And the fourth network address, will be 192.168.1.128 plus 64 again, which will give you 192.168.1.192. Okay, let's see if we can increase anymore. Fifth network address, 192.168.1.192 plus 64 will be given 192.168.1.128 dot 1 dot 256. Okay, 256. Okay, so cannot increase anymore at 255 at the last address. So basically, okay, by using this new subnet mask, okay, basically I have 4 different groups. So let's insert another 2. So now let's key in our on the 4 address. Okay, so we have another address for subnet 0, subnet 1, subnet 2, subnet 3. Okay, and the subnet mask is the same that we use across the board. Okay, so how to calculate broadcast? Same thing, is 1 less than the next network address of the next group. So 192.168.1.63, 192.168.1.127, 192.168.1.191, and okay, fifth group is 256, right? Minus 1 is 255. 192.168.1.255. Okay, so same concept here. Network plus 1, I will have 1. Broadcast minus 1, I will have 62. So same thing here. 65, 129, 193. Okay, 126, 190, and 254. Okay, so this is how you actually, okay, given a specific network address with a subnet mask, how you split them up, okay, or do subnetting into smaller groups of address for efficient usage of the IP address. Okay, let's move on to question 8. So now I'm going to do variable length subnet mask. Okay, this is more for information because your practical test won't really be covering variable length subnet mask. We'll be making use of fixed length subnet mask that we learned, okay, for all the first few examples. Okay, so as mentioned earlier, for variable length subnet mask, okay, instead of using a fixed subnet mask for every group, okay, we are able to be more efficient by making use of different subnet masks, okay, in every subnet depending on the number of usable IP address that we use. Okay, but the concept is almost the same. It's just that we need to keep finding, okay, uh, the more appropriate subnet mask to use for smaller group of address. You can see that for question 8, okay, for today's requirement is that given this address 172.16.128.128/25, we're going to create 3 different subnet. One to accommodate 27 hosts, 9 hosts, 2 user IP. So you can see that previously we also learned how to find the appropriate subnet mask given the total number of usable IP address. So same concept here. We are doing question 8 now. Okay, so a /25. Okay, if we increase to /26, okay, that means that, okay, I will have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 24. And 26 is 1, 2, followed by 6, 0, 1, 2, 3, 4, 5, 6. Okay, so we have 6 host bit. Okay, so 6 host bit means that 2 to the power of 6, which will be equals to 64 IP. Okay, IP. Okay, so, okay, definitely we cannot use all 64. So 64 minus 2 because of the network and broadcast. Okay, network and broadcast, we'll be left with 62 usable IP. Okay, so definitely a /26 new subnet mask will definitely accomplished by 27 hosts or 27 usable IP. But definitely we need to try a more efficient subnet mask. So from 25, let's change to 27. Okay, which is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 25, 26, 27, followed by 1, 2, 3, 4, 5, 5, 0. Okay, so now we have 5 hosts bit, okay, which is 2 to the power of 5, okay, which will give me 32 IP. Okay, 32 minus 2, because network and broadcast, I will have 30 usable IP. Okay, so you can see that with the new subnet mask of /27, okay, I still have 30 usable IP, which still can fit my 27 hosts. So apparently instead of 26, I should be using 27. Okay, but let's try another a more smaller subnet. So instead of 25, 26, 27, let's try 28 to see whether can it still accommodate my 27 IP address. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, followed by 1, 2, 3, 4. This is my /28. Okay, so 4 host bit will be equals to 2 to the power of 4 equals to 16 IP. Okay, so definitely, okay, not enough to fit my 27. So it means that I should be using the /27. Okay, so it means that, okay, so as mentioned, the first IP address, okay, the first IP address that is given is always the network address of the first subnet. So I will have my subnet mask, okay, for my first group, okay, 225, 255, 255, 255.244 will accommodate my 27 hosts, okay, based on my calculation. Okay, because 26 too much, 27 just enough, 28 not enough. Okay, so but now a bit special compared to the previous number, because we can just keep adding to find the second and the group. Okay, but in order to find the second network address of second group, same thing, because we know that the first group have 32 IP address. So it means that in order to get the second network group, what you need to do is that definitely the first network address is 172.16.128.128 that we have learned. The second network address, if you remember, we always add in the total IP address for the first group. Okay, so 128.128, okay, plus in this case 32 IP, okay, which will give me 172.16.128.160. Okay, so now I have my 172.16.128.160. Okay, the network address of second group. Okay, but okay, the second group I need my host only, so definitely I shouldn't be using 26. Okay, because 64 too much. I cannot use 27, 32 IP. Okay, also like too much. So you can see that just now when we increase 28, it give me 16. Okay, so 16, okay, is still more than 9. Okay, but let's try out. Okay, from 25, let's increase to 29 and see whether the new subnet mask of 29 still fit. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26, 27, 28, 29. 1, 2, 3. Okay, so basically it's 3 host bit, which is equals to 2 to the power of 3 will be equals to 8 IP. Okay, so definitely not enough to support my line host. So it means that, okay, the second subnet should be using the more appropriate subnet mask /28, which is 255.255.255.240. Okay, so now we have our second subnet mask. Okay, so now you should be able to see that, okay, for variables and subnet mask, every subnet itself have a different subnet mask compared to all the previous example that we are looking at. Okay, so the tricky part now is, in order to find out the third network address of the subnet that is required, we need to 172.16.128.160, which is the network address of second group. You don't go and plus 32 because we are not using fixed length subnet mask, we are using variable. Because the second group, we are using /28240, and the total IP addresses in the group is 16 only. So instead of adding 32, we should be adding 16. We should be 172.16.128.176. Okay, so that will be the network address of the next group. Network address of the next group, the third subnet. So take note, for variable length subnet mask, in order to find the network address of the next group, you need to add the total address of the subnet mask that you find out for the previous group, not the default that you find out from the start. So the subnet 2, you only need 2 IP. So from 29 you have 8. So let's try out from 25. Let's change to /30. So for 30 I'll have 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 1 2 3 4 5 6 7 8, 25 26 27 28 29 30, followed by 20. So 2 whole speed will be equals to 2 to the power of 2, which will be equals to 4 IP. So 4 minus 2, because of the network and broadcast, I'll be left with 2 usable IP. So you can see that if I use /29, I have 8 IP. 8 minus 2 is 6. 6 is still more than 2. But if I use a /30, just now it gives me a 2. So that means that I should be using a /30 IP address. 255.255.255.252. So this will be the subnet mask that I should be using. And because of the fact that we need to calculate all the broadcast address, right? So we need to calculate the network address of the next group. So same concept as previously dimension, you shouldn't be adding all the subnet mask from previously. You should be adding the new total IP address of the current group, which in this case will be 4. So 176 plus 4, we will be getting 172.16.128.180. So now by having all the network address, you should be able to get your broadcast address, which is 1 less than the next address. So this is 172.16.128.159, 172.16.128.175, and 172.16.128.179. So very simple. Network plus 1 is 129. Broadcast minus 1 is 158. So you'll be able to calculate the range of usable address for every single group. So question 9 will be using the same concept of how you're going to actually calculate. So always remember that you should start from the biggest number of hosts to the smallest number of hosts.